Section 10.2 is called Displaying Data, Part 1. Like I said, I split this into two sections. And the first thing that we're going to talk about is the kinds of graphs that you would see very, very early in elementary school called pictographs. Pictographs use pictures, or use a picture, use multiple pictures usually, to represent tallies within categories. So some kind of picture is being used to give some kind of an image of what's going on. Sometimes the pictures actually are used for a purpose, like maybe you're counting flowers, so you use a flower as the image, that kind of stuff, okay? But they don't necessarily have to be. So here's my example that we're going to take a look at for pictographs. The Automobile Club of America considers holiday weekends to start at Friday, 6 p.m. and they last until Monday at 6 p.m. If 150 people died on such a weekend by 6 on Saturday, 80 more people by 6 on Sunday, and then 80 more people by 6, I'm sorry, not 80, what was it? 100 more people by 6 on Monday. Draw a pictograph of the data. So this is a happy-go-lucky kind of problem, right? Wow, man, happy stuff. So people are dying on the holiday weekend.
Like an epidemic or what?
I think you're thinking more like car accidents because of alcohol related, probably. So that's why I think the Automobile Association is cited in it, actually. There's my stylus. Okay. So we have three different values that we're going to be comparing on 3 different days, right? All of them sort of end by 6 p.m. on the day that we're talking about, so we'll reference them that way. So we'll talk about the deaths that happened by Saturday, by Sunday, and by Monday. And what we're going to do is we're going to draw ourselves some lines. And we want to have some kind of a picture that represents this happy situation. So the picture that I usually draw on this, let me get my right image, hang on. Is a heart. And what we want to figure out is we want to figure out, I mean, like, I don't know about you, but I don't want to draw 150 hearts. I don't want to draw 80 hearts, and I don't want to draw 100 hearts. So I want this heart to represent more than one person, and we get to make that decision. How many people do you want your heart to represent? 10 or 20 is usually what people go with. I'd like to do 10 because I want to show you something. I'm sorry, I'd like to do 20 because I want to show you something interesting that will happen if I use 20. If you use 10, it's fine. It just means that you're going to have to draw more hearts than I do, okay? All right, so how many people was it that we needed to put on the Saturday line? 150. And 150 is not evenly divisible by 20. 140 would be, though. If I had 140 and I divided by 20, how many hearts would I need? 7, right? Okay, so I'm going to paste on here 7 hearts. All right, I have my 7 hearts. They're all perfectly identical because of the beauty of technology. What else do I need, though? I'm supposed to have 150. I need a half a heart. So I can draw that, and that's actually one of the best reasons that I use this particular image is because if I draw half of it, it's very clear that it is half of that image. Whereas, for instance, let's say you chose to use squares. Drawing a half of a square might end up looking a lot like the square did itself, and it might be difficult to tell that it's a half versus a whole. So, images that you can break apart into portions easily. Circles would work fine for this too. If you had a semicircle, half of a circle would be pretty obvious. And then also, even if you needed to have like a 3/4 of a circle, you could draw that and it would make sense. You guys with me? Okay, so here is my Saturday. How many am I supposed to have on Sunday? 80. So how many hearts would that be? 4. Now, a couple of things. I'm going to paste mine on here, and I have the, of course, advantage of having used technology to do mine, but they need to line up. All right, I can't do like big hearts on the first line and tiny hearts on the second line. I can't sort of have 5 hearts on the first line in the same space that it takes me to do 3 hearts on the second line. The point is when we look at this to be able to make the comparison without actually counting, without actually being super detailed and looking at the key to make the comparison with the numbers and count, that kind of stuff, okay? Excuse me, how many am I supposed to have on Monday?
5.
Yeah, 100, which is 5. All right, so here's my 5 hearts, and again, we could actually look at this now and we can make a comparison very easily because they've been lined up properly. Every graph that we do is going to need 2 things. It's going to need a label, title, that says what in the world this graph is supposed to be representing. And more often than not, you're going to need some kind of a key. Not every graph needs a key, but sometimes they do. We already have the key on this one. We did it when we wrote down the heart equals 20 people, so we already did that part. But we don't right now yet have a title or a label on the graph. So what would we label this graph? Number of deaths
By 6 p.m.
We could put the 6 p.m. part in there. That would be okay. I think at least we probably would want to reference that it was a holiday weekend because it feels a little bit funny to include the Monday when you're including the Saturday and the Sunday, you know what I mean? So this is the number of deaths on a holiday weekend. When in doubt, a little bit more information is better than not enough. So if you're not sure if you should include something, just include it. If it's part of the description, it'll be okay. Okay. Any questions on a pictograph? Pictographs are used a lot for the little ones. So I know some of you guys want to teach pre-K, kindergarten, first grade kind of ages. Pictographs will occur in there, okay? And they may draw who knows what kinds of shapes, but they're going to have shapes that are going to represent different quantities. Dot or line plot is our next example. This is a quick way to display data with fewer than 50 values. There's nothing really special about the number 50. It's just that as we draw this, you're going to be like, yeah, I wouldn't want to do this for 100 values. Okay? It's more like that. All right. Here's our example. The mass in kilograms of each child in Mrs. Good's class is as follows. We've got this example. This has got to be a middle school classroom. I just taught a lesson in my other class about kilogram conversion to pounds and so forth. Yeah, got to be middle school classroom because these weights are too heavy for small children. Okay, so we've got all these weights of kids, and we're going to create a dot or line plot. So let me show you how that works. First thing I want you to do is I want you to draw a horizontal line. Leave yourself a little bit of space there if you're doing it at the bottom of your paper. What you need to have underneath there is you need to have marks made for the different values. So taking a look at your data, what is the smallest value you see? 39, and the largest? 49, and maybe those weren't the 39 and 49 you see, but that's okay. Okay? So we need to have sort of hash marks along this horizontal line here at the bottom from 39 all the way to 40. And they need to be roughly equally spaced. I mean, I don't want you getting out a ruler or anything here, but it shouldn't be deceptive looking. That is not the point of creating this graph. Our point is to make it very clear and obvious what we're doing. So if I mark this one as 39, and I decide that this is 40, then all of my hash marks need to be about that distance apart. You don't necessarily have to label every single one of them. If you want to label every other one or every 5th one, depending on the data that you're working with, that would be okay. So mine are, I've labeled every other one except that I labeled evens and I had my 2 endpoints. I mean, somebody looking at this can figure out, oh look, it's halfway between where they marked 39 and 40. It would be, or 39 and 41, it would be 30, it would be 40 kind of thing. They could figure that out, okay? So you've got this grid, if you will. And what you're going to do is you're going to go through this data one at a time. So 40 is the first piece of data, and you're going to do, you have two options. You can do a dot. That's okay. That's why they call this a dot plot. But a lot of times what you'll see instead is a small x used, just because it's a little bit more obvious that it's there. Sometimes if you do a dot and it's too faint, somebody might not see it, kind of thing. But a dot or a small x. Okay? So that's my first piece of information, the 40. The next one is 49. Now you have to be careful, and I have to be careful because my screen's a little bit different than you looking on your paper. Your value should look about the same size. Okay? So I need to have an x again. The x needs to be above the 49 at about the same height. Okay? We're going to keep going down our line of data. The next one's 43. So I have a line, an x or a dot above the 43. And then I have the 48. So now I've got a value of x above the 48. And then I have 46. I have 42. $49. Okay, this 49 actually is a duplicate, so what do? Well, I stack it on top. Okay? So now I've got two x's stacked on top of each other at the 49. And I'm about to have a 39. I have a 47. I have another 49. So I stack it 3 tall now on top of the 49. 42. And 41. I have 42 and 39. So now I've got 3 on top of my 42. The 3 on top of my 42 should be about the same height as the 3 on top of my 49. And then I've got a 39. I have a 41. 40. 45. 43. 44. And 42. So which one occurred most frequently? The 42 did. Okay. So this is virtually speaking the graph. We are missing one detail to make it complete. A title. We need a title for this graph. What in the world might a title for this graph be?
Mass in kilograms of Miss Good's class.
Yes, and I'm glad Madison said in kilograms because that matters, right? If this is the mass in weight in pounds, that is to say if it's weight in pounds, these would be small children. This would be a preschool, kindergarten, first grade age class. But in kilograms, this is middle school to high school potentially. These are heavier weights, kilograms of children. In Mrs. Good's class. By the way, that was the name of my daughter's pre-K teacher, Mrs. Good. Isn't that a wonderful name? I think it's great. All right, next one. So you guys can see also on this why we don't want to have 150 values, right? Yes.
The, like, x equals a value.
We don't need to on this one because it's always every single value is a single data point on this one. Over here on this last one, the pictographs, usually the picture doesn't necessarily anyway reflect one person or one value, but on a dot plot or line plot it will. Yeah, good question. You could provide a label down here that says kilograms. That wouldn't be the worst idea ever, just as a further reference point that you're working in kilograms, but it isn't a necessity necessarily so. All right, the next one is a stem and leaf plot. This is akin to a dot plot, but it's drawn vertically. And the numbers on the left are called stems. The numbers on the right are called leaves. Have you guys seen stem and leaf plots before? Yes. Stem and leaf plots are very useful for looking at grade disbursements. That's where I find them to be most useful in my job. So let me kind of show you what a stem and leaf plot would look like with some grades. So these are the grades from a first exam. And we're going to make a stem and leaf plot for the data. Now, kind of like what we just did on the last one, it's useful for us to look and see what's my smallest, what's my largest value, so that we don't end up making more of a graph than we really need. What is the smallest data value in this data set? 40, what was it? 3? Okay, 43. And the largest? 94. Okay, so our stems are going to be the tens digits. So I need tens digits that represent everything from 40 to 90. So I'm going to have, and you can choose whether to do it from 4 down to 90, 4 down to 9, or from 4 up to 9. It doesn't really matter. I've seen it drawn both ways. I kind of like the 9 on top the best, personally, but I've even taught it both ways before too, so whichever it really is fine. And what we're going to do first is a lot like what we just did on the last plot. We're going to go through our data one at a time, and we're going to write the numbers down. So when I see 87, I'm going to go on the row that has an 8, and I'm going to write a 7 on the right-hand side of it. And then I see 94, and I'm going to do the 9, and I'm going to write a 4 on the right-hand side of it. 82, the 2 is going to go next to the 7 in the 8 row. 89, 67, 90, 74, 87, 89, 76, 58, 43, 53, 80, 94, 77, 74, and 90. Okay, are they all in there? Does yours look like mine, more or less? Okay, this is the most practical way to actually create the initial graph, but this is not a completed graph because it's not very visually helpful to see it written this way. The reason it's not is because, for instance, on the row that's got the 9 at the top, you can see we had a 94, a 90, a 94, and a 90. It's a lot more visually appealing and easier to work with some things we're going to do later if we put those in order. So what we're doing next is going to be, technically we would call it an ordered stem and leaf plot, but if you ever hear me say draw a stem and leaf plot, this is the final version that I'm expecting to see, what we're about to draw. So we're going to draw another vertical line. We're going to write the same 9 down to 4 that we had before. And we're going to write them in order, smallest to largest. So I have 2 90s, 2 94s. Now my row with 8 on it is the longest row, and I need to make sure that things line up again. So I don't want like the 4 values that are stored on the 90 row to take up the same space that 6 values does on the 80 row. They need to line up. So this would be a 0, 2, 7, 7, 9, 9. And then on the 70s row, I have 4, 4, 6, 7, 67, and then I've got 3 and 8, and then 4 and 3. So in looking at this, again, if you turned this on its side, right, like imagine taking my screen up here and flipping it like this, or turn your head like this, right? Can you see how it looks like the last graph we did?
Yeah.
It's just that we have values in those leaf spots instead of little X's. Okay? And in a sense, what we've done is we've sort of categorized the data into certain, in this case, grade categories. Right? We've put them in sets of 10 grade categories. All right, we need a couple of things on this. We need the title. We also actually will end up needing a key. Okay? So let's start with title first. What do you think the title might be on this particular display?
Grades from the first exam.
Yeah, exactly. Grades from the first exam. Now, a key for this looks something like this. I don't care which data value you pick, but you're going to pick a data value, you're going to write it down. So I'll just pick the first one that sort of is appearing here, 9/0. This 9/0 means what? Yeah, this is a grade of 90. So that's what you're going to write down for your key. Are we good with that? Excellent. Okay.
So you just do one of those because then you know, like, oh, well, that 8, 0 equals 8.
Yes, exactly. Just one of those is enough. Yeah. Any other questions?
So keys are needed on every one of these kinds.
On stem and leaf plots, yes, that's true. Another variety of a stem and leaf plot is what's called a back-to-back stem and leaf plot. What these are is they're two stem and leaf plots combined together to show sets of data in comparison. One of them will have the leaves to the right, like we just drew. And on the other one, we're going to draw the leaves to the left. Okay, so the first thing we're going to need to do in order to do this problem is to create the other stem and leaf plot in order for us to merge them together. Okay, so this next information is the data from a second exam. Okay, grades from a second exam recorded below make a back-to-back stem and leaf plot for both sets of data. I'm going to make the first stem and leaf plot from this set of data. That's where we're going to start. Okay, so what I would do is I would write, I know you've got a lot of space here on the bottom of your page. Go ahead and use sort of the space up here in the top right-hand corner to do what we're about to do so that you don't use up all your space and then like flipping over pages and stuff like that. So put them up here in the top right-hand corner. All right, so what we're going to do is we're going to first look and say what's the largest and smallest values. So what is the largest value? There's a 99. And the smallest? 64. So I need a stem and leaf plot that I will move mine in a minute here so that I have more space, that has 9 down to 6. And we're going to fill in next to it all of the data. So I'll let you do yours while I do mine, and we'll just make sure that we all have something that looks pretty close when we're done. I didn't do mine in order yet, so yeah, I would do the one that's just not in order and just stop there for a sec, okay? Does everybody's look as lopsided as mine? So one of two things happened. Either the students studied a lot for the second exam or the test got easier, right? So a lot of A's on a test. Okay. Does everybody have this picture done? Okay, what we're going to do next is I'm going to shrink this picture up so that I have some more space to work. Okay, I'm trying to figure out where to put it. Well, we'll put it here for now. I'm going to use this data set, and I'm going to draw it in such a way. I know that I'm going to need eventually from 9 down to 4 because I have data from 9 to 4 on the other set of data as well. So I'm going to make my chart from 9 down to 4. And I'm doing this leaves and the stem rather in the middle with a bar on, vertical bar on both sides, okay? And what I'm going to do is I'm going to take the data that I just squished up and move to the right, and I'm going to put it in order now on this other graph. I've got to get mine closer because I'm not going to be able to keep going back and forth between these. Okay, so on the first row, the 90s row, what's my smallest? 92?
Yeah.
Okay, so 2, 3, 4, 5, 5, 6, 6, 8, 9. And then in the 8s, I have 1, 2, 5, 6. Then I have 2, 4, and 4, 6, 7. And of course, you're noticing that it's all lined up like I mentioned earlier, right? Okay, so everybody's look pretty close to that. Okay, good. And what I need to do, and what you're going to do, is to flip back and forth between this image and this one. And we're going to do the first data set, which we created, and we're going to flip it around so that it's on the left-hand side of the graph. So, for instance, this says 0044, right? So over here, I'm going to write those values in, but I'm going to do that going to the left. 0044. Okay, is everybody with me on this? You're going to write it backwards order. So, but it still needs to be lined up, you know, along the middle. My next values were, what do I have? 027789. 027789. And then
I don't think there's an 8. I
Is
think it's
there-
9,
99. Okay. Yes, you're right. And then I've got 4467. 4467. I have 7. I need 3, 8, and 3. What are the two pieces of information that I do not yet have that I need? Title and key. All right, so the title, we'll just do a different one this time. 6/7 is a grade of 67, right? What's my title?
Test scores
Scores
from
from both exams.
Okay, so
first and second exam scores.
that sounds good. First, I was trying to condense it, something like that too. First and second exam scores. And it should really, I didn't make mention of it when I did it, but it really should make sense to you that we put the left-hand side as the first test scores and the right-hand side as the second. Right? That sort of makes sense that it would be in that order from left to right. Okay. Next information. Grouped frequency table. A grouped frequency table is a table, technically not a graph, it will be a table, that shows how many times data occurs in a range or classes or intervals. So in some sense, it's kind of like the stem and leaf plot where we're grouping some data together and giving it that name and categorizing everything into that location, that category. So we're going to use that same second data set of information that we just did. So if you want to sort of be flipping back and forth in terms of the stem and leaf plot you did, because it's a little bit more helpful because you put it in order, right? You might want to do that. What we're going to do here is we're going to use this data to create this grouped frequency distribution or grouped frequency table. So the way that it looks like is that we're going to draw column header. This column header is the column header of grades. We're going to have a tally column. Now, because we've already done a stem and leaf plot with this data, you're going to feel like, what was the point of the tally column? Okay? But generally speaking, you haven't done a stem and leaf plot before you get to this point in this particular problem. You would have been given a brand new data set and starting from there. Okay? So I'll show you why this works or how this works out when that's the case. And the last column is the frequency column. Okay. So usually when we group this data together, we want to group it in a way that makes sense. Okay? So when we're talking grades, we're probably talking our standard grading scale kind of grouping, right? If you were talking about something that's not grades, at the very least, you'd want to make sure that the data is evenly spread. So like if you do everything from, say like when we're about to do this one, we're going to do this one from 90 to 99, right? So this is a span of 10 values actually, because it's 90 to 99. Every category needs to be 10 values wide. We don't want one category that's 90 to 99 and the next category to be 85 to 89. It won't make sense, okay? So all the categories need to be the same, what we would call them width apart. So these would in fact be that case. So 90 to 99, 80 to 89, 70 to 79, 60 to 69. And as awkward as it might be, if we were to continue this data set, we'd do 50 to 59, 40 to 49. I realize those all have letter grades that match, but the grade disbursement, the distribution, needs to be even among the categories. Is everybody good with that? It's called width, how far apart these values are. Now what we would really normally do is we'd go through this and we'd make a tally. So when we see the 93, we'll make a slash mark in the 90s column. When we see a 98, there's another hash mark. We see a 67, there's another hash mark, right? You guys with me? Now, you have the ability to go back, because we've already worked with this data set once, and to count and to see how many 90s did we have, how many 80s did we have, 70s and 60s. And you could do that if you've already created those values. I'm not going to, just because that's not what you generally have as a reference point on the problem. So we have 92, 64, 86, 96, 99, 94, 96, 66, 82, 85, 81, 72, 95, 95, and 74. Okay, it's quick and easy. Now, you lose something here. What do you lose here?
What's repeated?
You lose what's repeated. So can you,
The grades that are repeated?
the actual grades, period, right?
Oh, yeah.
You actually lose the real grades. All you've done is categorize them. But in some sense, don't we do that at the end of the semester when we give you a letter grade anyway? Right? I mean, those of you who've worked really, really, really hard and ended up with an 89.2, and you have the professor that's sticking with that as a B, and somebody else who had that, that 79.5 that got rounded up, you both get Bs, right? You lose something in the disbursement. And so you do lose a little bit here. The frequency would then be just writing the numerical value that the tally corresponds to. So this would be 9, 4, 2, 3. That's all frequency means. It's the numerical digit that we associate with the tallies. And we need a title. So what would we like to title this lovely group disbursement, group frequency table? Second exam grades will work. You could say grades from a second exam, or something of that nature. If you're teaching and you're trying to get a feel for how many kids did what, and all you really wanted to know is how many A's, how many B's, how many C's, how many D's, this is kind of what you do too. You're just counting, right? This is one way to look at the disbursement. You lose a little bit, but you gain some kind of perspective of how well overall the class did. All right, histogram's the next one. Now, there are two graphs that we're about to talk about that are very, very similar. So once I talk about the second one, I'm going to focus really specifically about the differences between the two. But the first one we're going to talk about is a histogram. A histogram is made up of adjoining rectangles or bars. The categories are shown along the horizontal axis and the frequency along the vertical axis. Now, this is your book sort of definition, but you've probably also seen, so this is like a bar graph where the bars go up. You've probably also seen the bar graph where the bars go to the side. So you could turn this on its side depending on what you're doing, and that would be okay. Notice the key word here is adjoining, as in touching. So these bars touch one another. The categories, usually when we talk about a histogram, somehow feel continuous. Like they're really not categories. I mean, they really are categories that are almost like right next to each other, like grades. You know, like not A, B, C, D, but like the numerical values of grades. Somehow it makes sense to put the numbers along a number line and for the values to touch each other. If you were doing a graph where the categories were more categorical, like male, female, you probably wouldn't be using a histogram because it doesn't really make sense for those values to be sort of beside each other, because that beside each other makes it sort of feel like that somehow there's some kind of continuity between the values. So when we're going to do this one, we're going to use the frequency table that we just created to construct a histogram showing the numerical disbursement for the data from exam 2. So that's a lot of words for what we're going to do. What we're going to do is going to draw a histogram. So you're going to draw your vertical bar, your horizontal bar. Because this is a horizontal axis, like an XY axis, it really makes more sense to start with the lower values. I mean, just does. If you start with the higher values, it's not wrong. It's just not very natural, right? We usually do smaller to the left, larger to the right. So it does make sense for us to start our category with 60. And, sorry, here it is. Here's my 60. And then the next category would be 70 and 80. Notice I'm not putting in the, here's 90. And technically it would be up to 100 at this point. I'm not putting in the 99s because the bars are going to touch anyway. Okay, they're going to touch anyway, so I'm not too worried about the ending being the 99 versus the ending being at 70, or not 99, but 69 is versus the ending being at 70. Okay, this is grades. So when we're dealing with a horizontal vertical axis, we need to write down labels for our axes. So these are grades on the exam. Your vertical axis is going to be the frequency, okay? As in how many people got a grade in this category. So what is the smallest frequency of your grouped frequency table? 2. And what's your largest? 9. So we need our frequency to include all those values between, but it really wouldn't make sense to start with 2. It'd feel kind of funny. So we're going to start it with 1, recognizing that it's not going to be a value we have anything at. And as we're doing this, I didn't make mention of it before, but you need to have them again evenly spread apart, just like on the horizontal axis. I did it, but I didn't say I was doing it. And because I don't have as much space as maybe you do, what I'm going to do is I'm going to have each of my hash marks be 2s, which we're allowed to do as long as we label it. This is 2, 4, 6, 8, 10. I can go up to 12 and so forth as high as I need. I only need to be able to go up to 9, you told me. But this would be one way of doing my frequency.
So the frequency is how many of the grades we have?
Frequency is how many of anything you have. How many times something happens is what's called its frequency.
Okay.
So like if you said, what's the frequency of you working out? Well, how many times do you work out in a given week or whatever it is? Frequency. All right, so let's look down here at the frequency of these grades then. In this category that's sort of happening between 60 and 70, how many grades did I have? 3. So I need a vertical, not a vertical, I need a bar of height 3. Something like that. What about in the 70 to 80 category? 2. So I need a bar of height 2. And it should reasonably look, compare it to the one next to it, like 2 compared to 3. How about from 80 to 90? 4. And I'm a little bit off in terms of my spacing. My bar from 80 to 90 is really not quite as wide. That's not a very good bar. They should all be the same width. And then 90 to 100, I had 9. Okay, I think that's about right for my 9. Everybody good with that? What am I missing? A title. I need a title for this. So what is this graph representing? Grades on a second exam. Okay, and then we have something called a bar graph. And you probably should look at this and go, wait a minute, did I just not make a bar graph? And in some sense you did. You made a graph that had bars on it. Bar graphs are slightly different than histograms. Histograms, as I mentioned, have this sort of data that sort of feels like it continues, right? these grades from 0 to 100 or whatever the grades are in your exam feel somehow continuous, right? I can have any value kind of in between here. Bar graphs usually have this idea that these are categories of grades, right? Like when we're in the middle of a semester and I'm assigning you grades, we all recognize that being close to the next letter grade means, you know, something as opposed to not being there, right? I mean, there's a difference, yes, but it's more sort of fluid. You're in motion of doing something. We're going to do this next bar graph, but we're going to do it as a categorical data as opposed to that continuous data, and you can see how the difference is. Oh, sorry. One thing to notice here is this right here, this word spaces. The bars will have spaces between them. Okay? All right, so we have the exact same disbursement. I'm using the same thing on purpose so that we don't have to keep counting things over and over again. We're going to draw that same horizontal vertical axis, except that our horizontal axis this time is going to actually be the letter grades, as in A, B, C, D. Okay? And we didn't have any F, so I don't need F on this particular data set. Again, you can go A from the left. You can do A's on the right. When it's talking about letter grades, there's really not a natural ordering like there was with the numerical values, right? We did numerical values. We said we should start with the smallest value. Well, there's really not that natural ordering. So if you want to start with the A's as opposed to with the D's, you could do that. Just so that it will match the picture I had before, I'm going to do my D's first. So I make a width, and I call it D. And then I need another width called C, but it needs to not touch the D. Should be about the same width as before, but not touching the D. And then I need a width, and I'm going to call it B, not touching C. And then my final width is A, not touching B. So these are the letter grades now, right? As opposed to numerical grades on an exam. And we're going to do the same thing on the horizontal axis, I mean exactly the same as we did before. It's going to be frequency. We're going to mark it out. This time I'll make my hash marks smaller and I'll actually use the value 1, 4, 5, 6, 7, 8, and 9. So here I've got 9 hash marks. I'm going to label every other one so that I don't have to have too much going on the labeling. And I'm going to write down next to this the label itself, which says frequency. Okay, is everybody good so far? Okay, so is there really a lot of difference in this graph than the other one? Not really. You're spacing things out. You're labeling the horizontal axis the letters instead of the numbers, but it's pretty much the same thing. How many D's did I have? 3. So I'm going to make a bar of height 3. How many C's? I think it was 2, right? 2. And then how many B's?
4.
4. And then I remember the A's, it was like 9, right? And they're separated into categories because at the point when you have a transcript, nobody knows what that letter number was, right? Do they? All they see is the letter. There is a category associated with it, no longer a numerical value associated with it. One more thing I need. What is it? Title. These are grades. You can write letter grades if you like. You've already written the word letter at the bottom, so you don't necessarily have to. But these are grades on, oops, a second exam. How are we doing? So far, so good? Excellent. All right, a couple more left. This next one actually is a lot like that back-to-back stem and leaf plot. This is a double bar graph. It's a bar graph that can be used to make comparisons. We're going to use our back-to-back stem and leaf plot in example 4 in order to create a double bar graph for the data. So kind of hold your hand on that double stem and leaf plot or that back-to-back stem and leaf plot, and we're going to create the data for that. And it is a bar graph, so they are going to be separated into categories. So here's my my vertical bar. Here's my horizontal bar. And we're going to make categories of letter grades. Now, because we are doing letter grades, we're going to have to put things into, you know, F through A, because that's how we make those categories. So the first, and I'll start with the smallest. Again, you could start with the largest if you'd like. The first category I'm going to let is be F. Now, it's a little bit different because I need 2 in the F column. Hang on, I should have done that differently. So these are both F. And then I need to skip a tiny space, and I need to have 2 set apart, and this is D. Skip a space, 2 set apart, and that's C. Skip a space, 2 set apart, and that's B. Skip some space, 2 set apart, and that's A. These are letter grades. And our horizontal, sorry, I said that wrong, our vertical, our frequency. Was 9 big enough? I think it was, right?
Yes.
Yeah, okay. And we'll write down frequency over here. And I'll label mine every other one. 2, 4, 6, 8, and 10. They aren't perfect, but they're close. They're not purposely misleading or very skewed. Okay, so what I need for us to do first is, if you have another color with your backpack, colored pencil, colored pen, grab it. That will be helpful. If you don't, that's okay. Just keep what you've got, and I'll show you how to fix yours differently. I'll do both at the same time on my screen so you can see how to make that look. Okay, so we already did our bar chart for our second exam, so that's the one we're actually going to start with. We didn't have any Fs. We only had Ds. That was our lowest grade. And how many Ds did we have? There's 3, I think, right? Okay, so in this D column, I have 2 little spots of equal width, correct? The first spot will be Ds on the first exam. The second spot will be Ds on the second exam. So in the second exam, we had 3 Ds, so we're going to make a bar of height 3 in the D column, the second D column. And I used blue on mine. If you have, well, we're going to do all of the second exam, and then I'll tell you if you've only got one color with you what to do. How many C's did we have? It was a 2, bar of height 2 in the second C column. B's was 4, bar of height 4 in the second B column. And then there were 9 A's, so we have a bar of height 9 in the second A column. So this should look pretty much like the last one you did. If you're using a color and you don't have any other colors with you, what you can do is you can cross-hatch. That's not what I meant to do. Let me try that again. You can cross-hatch the columns in one direction. Same direction on all of your bars. And then, whether you're using a different color or you're just using the cross-hatching, over here you're going to draw that same image that you did, and you're going to write down a key that says that this blue are the second exam scores, or second exam grades, or something like that. It's the second exam. My blue, diagonally drawn, whatever, are second exam scores.
So there's no F, like there just weren't any Fs.
There weren't on that particular test. There will be on test 1. So we're going to need that column in a minute. Okay, so now flipping back to your stem and leaf plot, how many, on the first exam, how many Fs did we have? 3 Fs, which is not good, obviously. But let's change colors if you have the change color ability. If you don't, it's okay. You're going to draw a first bar of height 3 in the first column for D, or for F. How many Ds were there? 1? So we're going to draw a column or a bar of height 1 in the first D column.
So there doesn't need to be space between them if they're both like the same grade.
Correct. There's no space between the two Ds. Okay. And then how many C's were there? 4. So right in the C column, we're going to have a 4, like that. How many B's were there? 6. So we're going to have a height, let me try that again. Height 6. And then how many A's were there? And then if you're doing this one and you don't have the colors with you, you can cross-hatch them the other direction. Or you could do it vertically or horizontally, but something that's different than what you already did. So this pink, I used pink. Box where the diagonals went this way on mine are the first exam grades. So you have to have a key on this one, right? You do. What else do we still need? Title. What's the title for this?
First and second exam.
First and second exam grades. All right, any questions on that one? Okay, our last graph that we're going to discuss in this section is a circle graph or a pie chart. Okay, so this consists of circular regions partitioned into disjoint segments. The beauty of this graph and the purpose of this graph is it shows how parts of the data relate to the whole of the data. Comparison. It compares the last thing that you had before. I mean, the last one, the double bar chart compares things. That's true. But this has a comparison of part to whole instead of part to part. We've seen those things before, right? Odds and probability and ratios, right? Okay. So we're going to use the grouped frequency table in example 5 to construct a circle graph for the letter grade disbursement from exam 2. So before we can actually create our circle graph, we need some information to be able to write down, and we need to figure out how we use that information to create this circle graph. So if you flip back again, keep going back and forth, I know, to that grouped frequency table on example 5, you had some grades. And the grades used, and these are letter grades, so we had D's and C's and A's and B's. I think we listed our A's first, B's, C's, and D's, not that that matters. But let's just write down the frequency value that we had for each of them. How many A's did we have? 9. How many B's?
4.
Good. C's?
2.
And D's?
3.
Okay. And how many total grades is that? 17. Is it 18? 18, I think is what I have written down. 18 there? Okay. Well, what we need is we need to know what percentage of the grades are in each category. So what I really want, as I'm this is like a table that I'm creating. Let me give some labels to it. We'll do it this way. So these are the grades. This is the frequency. We're going to do percents because we're going to need this for our table, our chart here in a minute anyway, our pie chart. And then over here, we'll do one more column after that. All right, so how do I figure out the percent for the A's?
Put 9
Yeah, it can do 9 over 18, and then what? Yeah, x over 100, right? So actually, let me move what I just wrote here down further so that I'm not using it inside of my table. I'm going to run out of space. These are my A's. So if I solve this, what percent do I get? 50%. This is a 50. So up here in my table, this is going to be 50%. What am I going to do for my B's? 4 over 18 equals x over 100. And we're going to solve that. Now, for the purposes of what we're doing, we're going to round percentages to whole numbers. Okay? That is a typical way of doing it. It's certainly not the only way, but we're going to do whole numbers. So as you do this problem, whatever you get, round to the nearest whole value. So what do you get for B? Does everybody have 22? So this is 22%. How about for C?
2 over 18 and x over 100.
Now, if we've already done 4 over 18, should we know what 2 over 18 probably is? Half of it. So it should be 11%. I mean, you can still do the problem out, but you can also probably reason through that one a little. And we probably could average the 4 and the 2 to give us the D, which is 3 over 18 if we'd like. But what would 3 over 18 be as a percent? 17%? Now, here's a catch, something to be aware of, and I think there's even a question about this at some point. Because we've done some rounding, it may be that when you add up these percents, they don't equal 100. They should, right? If we didn't round anything and we kept all possible decimals to their greatest length, then it should be 100. But because we've done some rounding, sometimes it will add up to 99 or 101. So just be aware of that, okay? It's okay. I just want you to be aware of it. All right, there's one more column that we need to create. Any idea what that column might be? Very good, Catherine. Okay, so our goal is to create a pie chart in a minute here. And I don't think we're going to get to that part again today. But when we create a pie chart, we need to know what the angle is that the pie piece is. So we need the angle. So we need to have a degree measure for the angle. So let me talk you through how to find those angles, and then we'll pick them back up next class period. We set up these wonderful proportions that I'm going to now manipulate. Because I don't really want, for the angle, the value to be out of 100. What do I want it to be out of? 360. So I'm going to change each of these to be out of 360, and we're going to refigure each of the values with the angle measurement. And you might be like thinking, like, seriously, I already did this once? But both of these pieces of information are needed for creating the circle. Okay, they're both needed. So what do you get on the first one? 9 out of 18 equals x over 360 degrees. Yeah, and that should make sense. It should be 50%, half of 360. That's 180. How about B? 80. Taylor has 80. Does everybody else have 80 as well?
Yeah.
Okay, good. Well, let me put these in the, and I'm not, yeah, I am, I'm ready, right? Okay, so this one's 180 degrees. This one's 80 degrees. The next one should be 40 degrees, better be because it's half of 80, right? And the last one should be halfway in between 40 and 80, otherwise known as 60. You got it, good job. So what we're going to do next time, first of all, I'm going to do my very best to remember to bring protractors. I have one up here because someone found one hanging out in the room the other day. This is the only section in this class they're going to need a protractor for, so you don't need to go buy one. But you will need it if you haven't already taken geometry and measurement when you do geometry and measurement anyway, so that wouldn't be a bad thing to have. And they're seriously like 50 cents to $1. They're very cheap. My suggestion, if you do decide to purchase one, is to purchase this plain, simple little plastic one, because they're a lot easier to work with than the cool ones that have like the swingy arm things. Yeah, that's really not very helpful in terms of usability. So this is just the plain, simple ones work the best. So what we're going to do is we're going to draw this picture with the circle graphs and our protractor when we come back next time.